certain radical functions whose antiderivative is not automatically found by simply writing the radical into its equivalent exponential expression. So how do we do, or how do we find the antiderivative of such functions? For example, we are given the antiderivative of the square root of 3x plus 2 with respect to x. So in this case, we say that we cannot automatically write the quantity of 3x plus 2 raised to 1/2, being it the equivalent of the square root of 3x plus 2, and find the antiderivative by applying the power rule. Because our radicand is already a binomial. So in this case, what we need to do is to use the substitution method. When we say we need to substitute, we are going to use one single variable to represent our radicand, or the expression inside the radical sign. So, let us use the variable u to represent 3x plus 2, which is our radicand, the expression inside our radical sign. And because we are given u is equal to 3x plus 2, we also need to find the derivative of u, which is represented by du. And to find the derivative of du, we are going to get, of course, the derivative of 3x plus 2. And 3x plus 2 is a polynomial expression. The derivative of 3x plus 2 is 3 with respect to x. Alright. Now, because we have u being it the equivalent of 3x plus 2, we can rewrite our integral to the square root of u with respect to x. However, we see that our variable is u. And what we have here is a derivative of x. So, we can go back to the derivative of u, which is equal to 3 times the derivative of x, so that we can also substitute the derivative of x by the derivative of u. Because this is what we need to represent our integral of u. So, in order for us to solve for the derivative of x with respect to the derivative of u, we only need to remove 3 beside dx. So, to remove that, we need to divide both sides by 3. So, 3 times dx divided by 3 will become dx. And du divided by 3 will become du over 3. Meaning to say, we can change dx or substitute du over 3 to dx so that we will no longer have dx in our expression. Therefore, we will get the derivative of the square root of u times the derivative of u over 3. This time, we have already the variable u and the derivative of u. Now, we can now rewrite the square root of u into an exponential expression so that we can now find, or we can now apply the power rule of antiderivative. And writing the square root of u to its exponential expression will give us the integral of u raised to 1/2 and then du over 3. Now, we can already get its derivative or antiderivative. Therefore, by applying the power rule, we will get u raised to 1/2 plus 1 over 1/2 plus 1. And then, because we have du over 3 and we are already integrating, du will no longer exist in this computation or in the process. So, what we will have is 1 over 3. Okay? Because du over 3 means 1/3 times du. But since we don't need du anymore, we have 1 over 3 plus c. So, we continue our process. We have u raised to 1/2 plus 1 over 1/2 plus 1 times 1/3 plus c. And then we simply simplify, or we have to simplify our fractions in the exponent and our fractions in the denominator. We will get u raised to 1/2 plus 1 will give us 3 over 2, which means that our denominator, which is 1/2 plus 1, is also 3 over 2. Then times 1/3, and then plus c. All right, because we have a denominator which is also a fraction, we have to get its reciprocal and multiply it to the numerator or to the entire expression of the first expression we refer to. So we will get 2/3 times u raised to 3/2 times 1/3 plus c. Because we have 2/3 u raised to 3/2 being multiplied by 1/3, we are going to simplify 2/3 and 1/3 by multiplying them. And because we are multiplying fractions, what we need to do is to multiply the numerator by the numerator, the denominator by the denominator. So we will get 2 times 1, which is equal to 2, and then 3 times 3, which is equal to 9. Then we copy u raised to 3/2 plus c. Now, 2 over 9 times u raised to 3/2 plus c is not yet our final answer. Because in our problem, what we are given is a variable x, not a variable u. So what do we have to do? We need to resubstitute the value of u, which is 3x plus 2, in our final answer. So that means that we have 2 over 9 times the quantity, which is our u, times the quantity of 3x plus 2 raised to 3/2, and then plus c. This is now our final answer. Meaning to say, the antiderivative of the square root of 3x plus 2 with respect to x is 2 over 9 times the quantity of 3x plus 2 raised to 3/2 plus c. Alright, we will have another example which is parallel or similar to this problem. We are just going to change the radicand and we are going to follow the same process so that you'll get accustomed to how we find the antiderivative of a radical function whose radicand is a binomial and not a monomial anymore. So we are going to remove all these things and change the problem. Suppose we are given the integral of the square root of 6x minus 1 with respect to x. Again, as we have discussed a while ago, we are going to apply the same process by using substitution method. So, we are going to use one single variable to represent our radicand. So, let's use r. Let's use r and let r be equal to 6x minus 1. Now, because we have written r in terms of x, or we have substituted r to 6x minus 1, we also need to get the derivative of r. So, dr will be equal to 6 dx. And then let's proceed by getting dx in terms of dr. Because we have dr is equal to 6 times dx, we need to divide dx by 6 and dr by 6. So we will get dx is equal to dr over 6. Alright, now we can write the integral of the square root of 6x minus 1 with respect to x in this form. We will get the derivative or the antiderivative of the square root of r times dr over 6. Remember, r is substituted to 6x minus 1 and dr over 6 is substituted to dx. Okay? The next step, you are right, we need to write the square root of r into its exponential expression. And that would be r raised to 1/2 times dr over 6. Now, we are ready to apply the power rule of antiderivative. We will get r raised to 1/2 plus 1 over 1 half plus 1 times 1 over 6 plus c. Again, 1 over 6 is from dr over 6. Because we are already anti-differentiating, we can now remove dr. And since dr is removed, what remains in the denominator is 1. We copy the in the numerator, and then we copy the denominator, which is 6. Now, we will simplify r raised to 1 half plus 1, and 1 half plus 1 in the denominator. 1 half plus 1 is equal to 3 over 2, or 3 halves. So, we will get r raised to 3 halves over 3 halves. 3 halves is our simplest form of 1 half plus 1. Okay? Times 1 over 6 plus c. Again, we get the reciprocal of the denominator. We will get 2/3 r raised to 3 halves times 1 over 6 plus c. Now, we are ready to simplify 2/3 and 1/6 by multiplying the numerators and the denominators. So, this will give us 2 times 1 equals 2. 3 times 6 equals 18. R raised to 3 halves plus c. So, in this case, we have to simplify two things. First, 2 over 18 can still be simplified further. It can be written in a simple fraction. And r raised to 3 halves is not yet the final expression, because we need to resubstitute the value of r, which is 6x minus 1. So, we will get 6x minus 1 raised to 3 halves, and then we go back to 2 over 18. 2 over 18 can still be divided by 2. We divide both the numerator and the denominator. 2 divided by 2 equals 1. 18 divided by 2 is equal to 9. Meaning to say, the antiderivative of the square root of 6x minus 1 in terms of x is 1 over 9 times the quantity of 6x minus 1 raised to 3 over 2 plus c. This is how we find the antiderivative of a radical function which is written or which comes in a binomial form and not a monomial form anymore. But next time, we will be finding the antiderivative of a radical function with a monomial being multiplied to it outside, or a binomial or even a trinomial outside the radical sign. Okay, so I hope you learned something today. I hope you learned something from this simple discussion on finding the antiderivative of a radical function, which is no longer the radical of a monomial.